Could you talk about the criteria that would go into choosing HPLC or flash chromatography for your separation?
So for us, we use HPLC less for full separation and more for reaction monitoring or reaction checks. And so what we typically do is we'll perform a reaction, take a small portion of it and make a sample, and then use that to give us data to further optimize the system. So we'll use it to understand reaction conversions, comparing peak areas of a starting material to a product, or even in some cases to an impurity that we may want to mitigate. And understanding these conditions lead us to this point, we need to either dial back or move forward, maybe change a certain reagent, increase a certain equivalency. But we use HPLC truly to understand the reaction's progress. That's what I learned to use HPLC for when I was in industry. We did what were called in-process checks, where you would take a reaction and as it's going, sample it to see how far the reaction is complete. And once you hit a certain threshold, maybe 5% or less of a certain compound or 10% or less of a certain compound, then we know that we can move on to the next reactionary step or to the next operation. But for us right now in my lab, it's truly just to make sure that reactions are performing as necessary, to help with method development. For the flash piece, that's where we really get into isolation and purity and understanding, how best to get to that product of interest and to make sure that it is obtained in a way that makes us feel good, right? Being able to say, hey, I've got this product. Yes, by HPLC, this reaction is fully converted. There's no more starting material left behind, but there are other things in the system that either maybe HPLC didn't pick up or our method may have had it run off of the window that we're measuring by. Maybe its limited detection is too low. Maybe that byproduct isn't UV active. And that's where chromatography, such as flash or even TLC to do other checks, is really useful because now we've got other tools that we can use. Using TLC, we can then stain, and the things that might not be UV active that HPLC doesn't see, we can now see using different stains to identify different functional groups or different moieties. And then using that knowledge, we can say, all right, we know that there are these other things in the system. How do we separate it away from the product of interest? And that allows us to get really good, maybe even crystal data if that molecule is purified very well, NMR data, proton, carbon NMR, IR if necessary. Some cases we might even want to get melting point data if we're trying to relate this back to a teaching lab demonstration. And so good chromatography in either of these stages kind of works hand in hand in method development, which is what a lot of my group does.